Call is now being recorded.
Good day, dear students. Today we will be entering topic 2 integration, subtopic 2.3 techniques of integration. Let's look at our learning outcome for today. At the end of the lesson, students should be able to find the integral by using substitution method, perform integration by parts, and also solve integral of a rational function by means of decomposition into partial fraction. So first of all, we have to make sure when we are supposed to use substitution and also integration by part, and also partial fractions, okay, by means of partial fractions. So when we use integration of substitution, it's basically when we come across functions of integration where it involve multiplication of a two function. So please be careful. When we are given multiplication of a two function, we are not able to integrate this term by term. It's not the same as addition and subtraction. So when it comes to multiplication, we have methods to solve this. One of the method is substitution method. And also for division, same rules apply for division. So when we have function that are divided and we need to integrate them, we can't integrate this term by term. We also have to use a method. Okay, one of the method is substitution. Second method is by part. And the third method, we only use it for rational function. So which means division. Okay, and this is also rational functions that involve only polynomial. We want to use partial fraction, it has to be a polynomial. Okay, now let's look at the first example, example 9, where we are supposed to use substitution method to solve this question. So notice that this is integral of a division. Okay, yeah? So it's in the form of division. Fx divided by gx. If it is in the form of division, bear in your mind that we can't divide this term by term. Therefore, we have chosen a method which is substitution, and given tips here that you should be the most complicated. So when we look at 6x and 3x squared plus 12, 3x squared plus 12 is slightly more complicated than 6x. So remember, this is just a tips. Okay, now let's see what is the second step. You need to differentiate your u. So differentiate u, we will be getting 6x. Okay, differentiate 3x squared plus 12, we will be getting 6x. And please find out what is du. Du is 6x dx. Now we are supposed to change all in terms of u. So 6x divided by 3x squared plus 12 dx is equal to integral of, okay, notice that 3x squared plus 12 can be replaced with u, and 6x dx can be replaced with du. Okay, so this is how we are going to change all in terms of u. So our integral here will become 6x dx, we are going to change with du, and 3x squared plus 12, we are going to change this with u. So now we need to integrate 1 over u du. So notice that by using substitution, we manage to transfer two terms into one so that we are able to integrate. So we can only integrate one term. We can't integrate division of two terms by term by term. Okay, now what happens when we integrate 1 over u? Please be careful that this is a special case where u is to the power of 1. So u to the power of 1, we can't integrate with adding power. So we need to use the formula, which is integrate 1 over u will give us ln u plus c. And step 5, we need to replace back all in terms of x. Replace back all u in terms of x. So u is 3x squared plus 12 plus c. So that's how you integrate 6x divided by 3x squared plus 12. Okay, I hope you can understand example 9. So we will do another example to understand better. Okay, now let's look at example 10. Example 9b. So example 9b, we are supposed to integrate negative 9 divided by x ln x. So choose u, and the tips here is u is the most complicated compared to x ln x. Ln x is more complicated. So differentiate u. So differentiate ln x, we will be getting 1 over x. And then please find out what is du. So du is 1 over x dx. Now we need to change all in terms of u, which means integral of negative 9 over x ln x dx. We are going to change all in terms of u. So negative 9, there's nothing to change in negative 9. So be careful. 1 dx over x. So dx over x can be replaced with du. Yeah, dx over x can be replaced with du. And ln x can be replaced with u. So basically, integral of negative 9 over x ln x is the same as integral of negative 9 over u du. And we can take out the negative 9. So all you have to do is integrate 1 over u du. So when you integrate 1 over u du, you will actually get negative 9 ln u plus c. Now we need to replace all u in terms of x. U is ln x plus c. So final answer, negative 9 ln of ln x plus c. So basically, why we use substitution of u when we get two functions and they are in the form of multiplication or division, by using substitution of u, we can change 2 to one function. So x ln x here is now u. So you are able to integrate if it is as one function. Okay, so I hope all of you are able to use substitution of u to solve integration. We also have another method to solve integration involving multiplication and division, which is integration by parts. So integration by parts, we have a formula where u dv equals to uv minus v du. And for integration of by part, we have tips for choosing your u, which is by using PAT or LOPAT. So what is LOPAT? LO stands for logarithm, P stands for polynomial, E stands for exponential function, and T stands for trigonometry. So if you want to use by part, and for example, example 10 here, if you want to use by part, it's quite easy to choose your u. So between x and exponent x, who will become u? So if we use LOPAT, notice that x is a polynomial and exponent x is a exponential function. So in LOPAT, polynomial comes before exponential function. Therefore, choice of u will be your polynomial. In this case, u is x. And we are supposed to choose u and dv. So this is much different from substitution of u. So substitution of u, we change all in terms of u, but by part, we need to change the question given as u dv. So one of the term will be u, the second term will be dv. So since x is already u, the remaining will be dv. So dv is exponent x dx. I hope you can understand this part, yeah? So once you choose u, the remaining will be dv. So you need to change this to the form of u dv. Okay. Next, what we are going to do, we are going to follow the formula. So in the formula, you need to take u multiply with b minus with integral of v du. So you need uv and v du. So we already have u, we already have dv, but we still need du and v to use by part. So how to find du? You need to differentiate u. So du dx is 1, du is dx. And how to find v from dv? we need to integrate dv. Yeah, okay, integrate dv, we will get v. Integrate exponent x, we will get exponent x. While using by part, you at the integration here, we don't have to write plus c yet. So we will be writing the plus c at the last step. Now how to use by part? X exponent x dx. Okay, how to use by part? Okay, first we write down the formula of by part. U dv equals to uv minus integral v du. So u dv, u is x, dv is exponent x dx. So we will get back the question u dv equals to uv. So what is uv? U is x, v is exponent x minus v du. V is exponent x and du is dx. So notice that multiplication of two function, we managed to change it to integral of one function so that we are able to integrate. Okay, now what is our final answer? So here we have x exponent x. Integrate exponent x, we get exponent x. Do not forget to plus c. So this is how we use by part. Now let's look at the second example for by part. Let's say we are given x square ln x. So it's important to recognize your u between x square is a polynomial, ln x is a ln function. Now if we look at the loped here, ln comes before polynomial. Therefore, the choice of u is ln x and the other one will be dv. Choice of dv is x squared dx. Yeah, so choice of u is ln x. So this is u. The remaining will be dv. Okay, now let's see how to answer the question. Okay, so we already have u and dv. To use by part, we need to take uv minus v du. So we need to, which means we need to differentiate ln x. So differentiate ln x, we will get 1 over x, or du is 1 over x dx. And dv here is x squared. So to get v, we need to integrate x squared dx, where we will be getting x cubed over 3. You don't need to write your plus c yet. So we are going to use this formula, u dv, integral of u dv. U is ln x, dv is x squared dx equals to u multiply v. So u multiply v is ln x multiply x cubed over 3 minus with integral v du. V multiply du, v is, v multiply du, v is x cubed over 3 multiply du, du is 1 over x dx. Okay, so this is key into the formula of by part. So here we have integral of x squared ln x dx equals to x cubed over 3 ln x minus integrate x cubed over 3 multiply 1 over x will give us x squared over 3 dx. Okay, so what happens when we integrate x squared? We will be getting x cubed over 9 plus c. Okay, so the final answer, x cubed over 3 ln x minus x cubed over 9 plus c. Okay, I hope you are able to do by part. Okay, now for our by part, we have alternative method which is known as the tabular method. Okay, but we have to be very careful. Tabular method does not work for all the question. Tabular method, when the choice of u dv, when we choose u, we must make sure u is only polynomial. For example, the two examples here. Okay, so the first example, u equals to x is a polynomial. Therefore, the first example here, we can use tabular method. Okay, whereas the second example, u is not a polynomial. U is a non function. Therefore, for example 10b, we can't use tabular method. Okay, so very careful. Okay, tabular method is another method to solve multiplication or division, but be very careful in by part. The choice of u must only be a polynomial. So tabular method is used only for by part, yeah. Okay, now let's look at the first example here. Okay, so let's say we are going to solve x square exponent x dx. So our uh, first thing to be concerned here is this is a multiplication of a two function. X square and exponent x is in the form of a multiplication. So multiplication of a two function can be solved by using substitution u or by part. So in this case, we would like to use substitution of u, where integral of u dv equals to uv minus integral of v du. So for in by part, when we want to choose u, the choice of u will be using the part. Okay, where in this case we have polynomial and exponential function. So the polynomial function will be your u, and exponential function, the remaining, will be your dv, exponent x dx. Okay, so as I told you earlier, if the choice of u is a polynomial, if the choice of u is a polynomial, we have another method which is known as the tabular method. So we would like to try tabular method here. Okay. So how to use a tabular method? Once you have chosen your u and dv, you need to do a table. Okay. So we have a table here where this is your u and this is your dv. So our u here is x square. Okay. So what you have to do with your u, you need to differentiate until you get 0. Okay, so first is x square. Second, when you differentiate x square, you get 2x. When you differentiate 2x, you get 2. When you differentiate 2, you get 0. That's when you stop, when you get 0. Now for dv, we need to integrate repeatedly. Okay, so dv here is exponent x. So how many times you're going to repeat depends on your u. So the integrate exponent x will give us exponent x. Integrate exponent x will give us exponent x. And again, we are going to integrate again, and again we will get exponent x until the step 0, until the last step. So we're going to integrate dv until the last step. So for this question, we are getting the same answer. The integrate exponent, we get another exponential function. Okay, that's what is written for tabular method. Now to get your answer, we are going to start with a plus sign followed by a minus sign followed by a plus sign, and the last is 0. So you can have a minus sign, but there is no function for it. Okay, so we always start with plus, minus, plus, minus. Okay, now what happens when you integrate? Okay, what happens when you integrate x squared exponent x dx? So how you're going to write your answer? You're going to take positive x squared multiply with exponent x. Okay, minus, because the sign here is minus, minus with 2x multiply with exponent x, and plus 2 exponent x, and plus c. Okay, so that's your final answer. Okay, x square exponent x minus 2x exponent x plus 2 exponent x plus c. We can also use by part, or we can use tabular method. Okay, now let's see for the same question. It's the same question here. Let's see if we didn't use tabular method and we use by part. Okay, like what we learned earlier. So what is by part? U dv equals to uv minus v du. So we need to recognize our u, where we already recognize u as x squared, dv as exponent x dx, and we are going to differentiate u, and we are going to integrate v. Okay, so v is exponent x, du is 2x dx. So what is by part? U dv, u dv exponent x dx equals to uv x squared times exponent x minus v du. V is exponent x, du is 2x dx. Okay, notice that we managed to separate this x exponent x multiplication into x squared, but here we still have multiplication, so we're gonna continue with our by part for second time. So x squared exponent x minus, let's say we take out the 2, so we are going to focus on how to integrate x exponent x dx. So this is again multiplication. So what we did, we managed to reduce x squared to x, but still this is in the form of multiplication, so again we need to use by part. Okay, by another by part. So to use by part, again we will be using LOPAC, where u is x, dv is exponent x dx, du is dx, and v is exponent x. Okay, so here this will become x squared exponent x minus 2. Okay, now we are going to key in into the formula uv minus v du. So uv is x exponent x minus integral v is exponent x, du is dx. So final answer, x squared exponent x minus 2x exponent x. We are going to multiply 2 inside. So negative 2 minus integral of negative exponent x will give us positive 2. Integral of exponent x is exponent x plus c. So notice that we are getting the same answer when we use by part. But it's a bit tedious because this question for by part is involving polynomial with power 2. So the higher the power, the more difficult by part is going to be. So advisable for us to use tabular method when we have u as a polynomial, especially the polynomial is in a higher power. For example, x squared, x cubed, and so on. It will be best to use tabular method. Okay, now I would like to end my video for today. So we have covered mainly two important techniques of integration in this video, which is substitution method and also integration of by part. In integration of by part, we also covered tabular method. So please be very clear to use tabular method. There's only one important thing that we need to consider, that u being a polynomial. Okay, that's all for today. I'll be seeing you in my next video with integration of rational function using partial fraction. Thank you, students.